This presentation is going to cover artificial intelligence and machine learning technologies and how essentially we can use it for big data and cloud related operation activities. Uh, Probably this is the agenda what we are going to cover. So essentially what we require to see first is state of the IT teams, what are the current state and like in how they are operating as such as of now, probably what are the challenges which are faced by them. After that, we'll talk about artificial intelligence and its adoption into industries and the enterprises, and essentially what are the benefits and appreciation what we get when you adopt artificial intelligence and machine learning into the organization. Then we'll also cover the artificial intelligence benefits for the IT teams. And last but not least, essentially a solution which provides the solutions or which caters to the challenges what we talked about during our slides, which will talk about our solution into the AI ops space for big data and cloud, which is Jambion. Okay, feel free to ask the questions probably through Q&A, and I will be happy to answer those questions. And you can always send across the questions as I'm talking through the slides. Okay, first let's go through the state as observed by the IT teams. Uh, So this is the state, right? As of now for the for the enterprise big data and the cloud stack. So there's a massive big ecosystem which is there, huge amount of technologies. When you talk about the big data, it comes up with numerous number of technologies. When you talk about the cloud, there are numerous offerings, numerous cloud services which are there, and same is for the other enterprise technologies which are there. And it's not only that there is a massive technology stake which is there, but also there is a huge amount of volatility which is there. So every now and then there are either new versions of these technologies which comes up, major or minor, or there is like major improvements in the technologies or quick shift into the way we are utilizing the technologies. And very recently, even since you have also been observing these technologies and these stacks, so very recently you must have also observed that the amount of technologies which get changed probably every 6 months or every year is quite high. So there's a good amount of volatility which is there in the technology stack and essentially also on the infrastructure side. So this is all about the ecosystem which is there. Now, when we talk about the technologies, essentially the in-memory technologies, there are technologies basically which get used for in-memory analytics. Probably some technologies are used for the big data, for the disk-based storages and disk-based operations. And probably some of the technologies which use hybrid kind of ecosystems, probably some part of that is lying into the in-memory things and part of that is lying onto the disk base. And these technologies exist everywhere. They are in the in-premise. There are also private clouds. Very many enterprises runs private clouds and huge scale private clouds. There are many technologies which many enterprises which are going to the public cloud. And essentially there are mix of organizations which also use the hybrid or multi-cloud, which means both private and public clouds being used at the same time for the organization needs. And last, there is a third aspect which is there in the industry. And as we work in the across solutioning the business use case, which is about the teams. And we have seen many over the years or in the recent past, there are many specializations which have come up in the teams. So people talk about the data engineering team, then there is a research team, there are data scientists which are there are compliance stewards which are there are data stewards, there is the infrastructure managers which are there, which takes care of operations, and last but not least, BI team, which takes care of the business intelligence and visualizations and analyzing the data which comes up from the analytics. So number of teams basically and specialized roles which have developed very recently, and we require to work in tandem for solutioning a business scenario or business use case. And all these teams, different teams, works in silos, right? They've got their own set of people, right? Probably data engineering team might be consisting of 15 people. Data science team probably might be a 30 people, right, who are working on creating the ML algorithms, AI algorithms, and working on modeling the data. And same is scenario for the operations teams and other teams. Now, all these teams basically requires to self-service themselves, right? They don't require interdependence across the teams, right? So they would, as they always aspire that whatever they require for their work, right? Probably data science team, if in case they require the data for their work, or data engineering team requires a fixed size of infrastructure for their work, they should be able to get that by themselves, right? They don't require probably an interdependence across the teams, or probably a huge amount of cycles so as to wait for their service, their request to get served, right? So there's a huge high expectations which is there, and diverse set of applications in these enterprises big data and cloud stack. So this is an important thing for us to understand as we get into the further slides. Next is, right, how the journey of the IT strategy has been going on, right? So what we have seen previously is what are the various technologies which are there, probably how the teams are, how the diverse teams are operating, and probably what are their aspirations. Now, next part is how the journey of the IT strategy has been going on, and monitoring is not new, right? All these things basically comes up, right? Every team which is operating, every technology which is getting employed for some work or delivering some business use case, or every application which is getting developed, all these things produces data, and this data requires to be crunched, this data requires to be observed, this data requires to be monitored. And monitoring is not new, right? This is going on since last 30 years or more than that, and that all started with probably collecting the data, aggregating the data into some PowerPoints or Excel based spreadsheets, and then sending them across, creating the reports manually, and then sending them across over the mails. So that's like, the first point what I've been talking about. It's like manual drudgery. Next is fast forward to 2014, and Gartner introduced a term like ITOA, IT Operational Analytics, where good amount of dashboards which came up, and probably good amount of visualization tools and technologies which have come up. So there have been some storages which are there, probably time series databases or something, and there have been some reporting engines or visualization technologies which have come up. And the visualization charts usually take the data from the underlying data sources which were there and used to present them onto the dashboards. And the title of the second point is very correct, which is death by dashboards, which means like once these things got arrived and these technologies basically were liked by the pupil, right? Essentially pupil end up creating lot many dashboards. So there were like, dashboards and dashboards and dashboards and dashboards. So this was like, probably too many dashboards, and for analyzing anything, right, we require to see lot many dashboards here, there, everywhere, just to understand, right, where the things are, and like, what are the issues, challenges, everything is all good, or are we seeing something. And it's really very difficult. Then we arrived to the a very good thing, right, which was like, APM, which was application performance management. So these were like probably the tools or platforms which helped, which were reactive in nature, right? So as the things happens, probably they used to present the outcomes or the monitoring or the analysis of like, how well it happened, or probably what is the state of the things after that has happened. So probably kind of reactive in nature. They were producing measurable results, right? So whatever the outcomes which were coming were really helpful, and they were able to observe all these technologies, all these teams across the board. And now at the fourth, right, there have been Devops Analytics, which has been there since last couple of years. And as we have been working across multiple customers for Fortune 100 organizations or Fortune 500 organizations, we have seen many organizations have these specialized roles, which are DevOps. And these DevOps, what they have been doing, DevOps team have been doing is they require to first have an expertise in all these technological stacks what we talked about, and then they require to assimilate the data and create the manual scripts, right? These scripts basically help them to do the statistical analysis, aggregation over the data, and they also define some rules over these scripts which help them to deduce the outcomes. So DevOps has been really a successful story till now. But very recently, in fast forward to 2020, right, there has been a great shift into the transformation into a digitalization journey. And this is AI ops, which is artificial intelligence operations. So this is employing artificial intelligence and machine learning in real. And there are new ways of working, right, which have come up, right? There are all together, right, which was not possible throughout all the journey, what we have seen in first, second, third, and fourth point. All these points basically have come up, and there are new ways, new outcomes, all together, something which were not possible by all these things are now getting possible. And we'll see those magic when I'm going to demonstrate the solution after this presentation. So there has been a huge opportunity to automate each and everything. Um, as we can see in the point number 3, there have been observations. Now here in the point number 5, in the AI ops transformation, we can see it's not only observations, there are causations also. And there is a good difference, right? When we observe something, right, what we are seeing is like, okay, this is the state, right? These are the things. But when we talk about the causation, it means we are not only observing something, but we are also causing something, right? So accordingly, we are also taking some actions. So that's the causation, right? So this is all together a transformation journey. And right now we are standing at a stage where there are AI ops and artificial intelligence, which is getting applied. And specifically in this slide, these presentation, right, what we are going to talk today, we will be talking about, right, how artificial intelligence and machine learning is helping us in big data and cloud operations and journey. Let's go to the next slide and see that. So what we are seeing here is an artificial intelligence is really coming into the adoption. Let me put some numbers here, and these numbers basically are done by the research, which is from the MIT slogan management review research with in cooperation with the Boston Consulting Group, BCG. Right, what we are seeing here is whatever the in the industry is, right, the executives, the leaders, the architects, or even the technological leaders, right, who work there, they around 85% of them, right, who have been researched, strongly believe that artificial intelligence is going to transform their organization. They are going to bring in a competitive advantage to the organization. So there's a strong belief in that. As we go into the second point, right, that's like 20%. What it says is it's only 20% have extensively created the offerings. So though 85% of them believe that yes, they are going to bring in the competitive advantage, and organization is going to leapfrog uh, compared to their competitors or other organizations in the same space, it's only 20% who have actually adopted, right? So there is a good difference in the ambition and actual adoption, and that's where the opportunity lies, right? So if in case we create something in artificial intelligence and that is going to get adopted, there's 65% to 80% probability of that getting adopted, because the state of adoption is quite low. And when something which is not being adopted as of now, and we believe that that is there, so that is going to come up in the future. So that's like probably this gap all talks about, right, the future opportunities which are there in front of us. And this gap is coming up because companies lacking the expertise in the pupil, artificial intelligence and machine learning expertise in the pupil, the analytics expertise in the pupil, and also the data which is coming up from the cloud or these big data technologies also requires to come in, right? It's easily required to get captured and accessed, and hence we are going to work on that. And last point is very, very helpful, which talks about the appreciation. So appreciation is whenever these are going to get adopted or someone is going to build the solutions using artificial intelligence or machine learning, there is going to be a good appreciation from the leaders, probably from the directors, VPs, GMs, or even CIOs or CEOs of the organizations. So senior leadership has always been supporting the business use cases for artificial intelligence. Just wanted to set the need for this one and the gap and the opportunities which exist as of now. Let's go on to the next slide. What we are talking here is the disparity in the adoption, quite the same as like what we talked about in the previous slide. Just giving an example, a major insurance company which is employing 110 data scientists has already 30 AI initiatives which are sponsored by the chief executive officer, CEO. So which means, right, 110 people in one organization are actually data scientists who are working on machine learning and artificial intelligence and working on the AI initiatives. Whereas on the other part, another large insurance company has only created the chatbots, right? So essentially, there are organizations which are really taking it up, as we have seen in the last slide, but it's only 20% of organizations which have really adopted it, right? And the left example is like, that 20% where like, people have really gone for it. Whereas there is a gap of 65% what we can see in the right example, right, where people are only creating chatbots. And the reason for this disparity perhaps is because of understanding of the people. The what we can say is like, the adopters and the passivers, right? Let's talk about them. Let's refer them as like, the adopters and the passive players, right? So around 12 times more understanding of what algorithms requires to be done and what data requires to be used. So that 8 times more understanding of like what data requires to be used. So this is a difference between the adopters and the passive players. So adopters have 12 times more understanding about, right, what all requires to be done, what all algorithms requires to be taken up, and what all data requires to be taken up. So that's the underlying reason, right, why organizations are lacking. So if in case we can work on assimilating the data, understanding what data is required, and probably what algorithms which we require to use, so that can drastically improve or transform an organization from a passive player to a adopter. And I'm focusing on these slides specifically for you to concentrate and focus on how we can have more understanding about the algorithms which can be used, and probably also on like how we can assimilate the data and can use that data. So that's like should be the focus as we move along in our technology journey over the years. And this is a barriers for the leaders. Attracting and acquiring and developing good artificial intelligence and machine learning talent has been a barrier for a leader, for an organization leader. Cultural resistance is always there because it's not so simple for anyone to adopt artificial intelligence. And what we are seeing right now is people are looking at AI or AI ops products just to hotwire this cultural resistance, right? So people don't require, so data science teams or other teams especially don't require to, or probably the operations teams or data engineering teams doesn't require to learn all these machine learning and artificial intelligence stuff. Probably what they can do is like they can hotwire all these things using some AI ops or artificial intelligence products, and we are going to talk about that product, right, which helps you to hotwire or remove out all these cultural resistance. And there's a limited AI related technological capabilities. Not many products are there, right, which helps you to provide artificial intelligence solutions or capabilities. And last but not least, we also require to come up with the business use case and actual requirements where artificial intelligence and machine learning can be used. Let's move to the next slide. We have already talked about the barriers for the IT, the leaders. Now let's see the barriers for the IT teams. So one important thing, right, we can go through this slide, but essentially the most important thing is ability to understand the data and ability to understand the algorithm is not there. So data is always required, right, for artificial intelligence and machine learning. No amount of sophistication of the algorithm is going to help you if in case you don't have any data, right? So data is the primary foremost need, and lot many organizations have not collected the data, right, which can be used for not only for training but also testing and hence upgrading our models and coming up with the accurate results of artificial intelligence and machine learning. So these are like essentially the barriers of the teams. So one is like data collection and understanding the data, and organization also requires to have the data available, right? If in case we don't have data, right, it's not going to work for no amount of algorithm or sophistication of algorithm is going to help us. So that's like primarily important thing what we require to do. This is an example where on ground, right, what are the things which are happening, right? So this is how we are bringing the operational intelligence using machine learning. So on the right side, if in case we see there are potential algorithms what we can use from the artificial intelligence and machine learning. And on the extreme left, there is a use case probably where these can help, right? So if in case we talk about supervised ML and AI optimization algorithms, probably they can help the server load balancing, dynamic server load balancing for more optimal utilizations of the feeds. Second example in the table is time series forecasting, and that can really help us to do a better capacity planning of the entire infrastructure and landscape. And same are the scenarios for the other examples in the other examples. So that's where machine learning algorithms there are, and we all know, right? There are multiple machine learning algorithms and AI algorithms which are available. Uh, there are class of supervised, unsupervised, and even neural network which are available. Now, based on the use cases, based on the data, probably what all requires to be taken up and what all data basically requires to be used, requires to be rightly chosen for coming up with the accurate results. Now let's see, right, how IT teams are getting benefited from artificial intelligence. So these are the real world problems or the challenges, right, what teams are facing. So let's talk on ground, right? If in case I'm executing something, I've created an application and I want that application to run for some business use case. Essentially, the most important thing is the correct execution of that application. Then the next important thing which comes up is that requires that application or that query requires to run very faster. So all these technologies what we talked about in when we're talking about the massive set of technologies in the big data and cloud, all these basically either get transformed into some applications or some queries or some kind of workloads or workflows, right? So essentially the need is so as to come up and execute them faster. Now these you must be wondering, right? There are some questions in the black and blue, right? The blue ones are something, right, which I wanted to highlight just because these are like the tough questions to answer. So can we get the execution time estimations even without executing something? So this is magical, right? I don't want to execute anything, but let me know how much time it is going to take, right? A program what we have written, an application what we have written, if in case we can get to know that okay, this is going to take 4 hours without executing, without hitting the cluster, right? So this is something magical. And these all things basically can be answered from the machine learning and artificial intelligence. What if in case I've got some query, and I'm executing it in some particular, say, business queue or resource pool, right? If in case I shift it to another queue, am I going to get a better result or better execution time or better performance? So it's really very difficult for someone to answer it, right? Because that's something, right, for the future. So we require a forecasting. So what we utilize here is like probably something which is forecasting. If in case I'm executing some applications or some workloads are executing, am I going to miss the SLA for those applications? Something which is going to happen after 8 hours, am I going to get to know that thing right now? Can I get to know that thing right now that I'm going to miss that after 8 hours? So this is also something really difficult to answer because that is something for the future, right? And it's only machine learning and artificial intelligence which can answer these tough questions. And one more question, which is probably the last question I would like to highlight, which is again in the blue, highlighted in the blue, is like will I get a faster runtime of my job if in case I don't execute it right now, if in case I execute it after 2.5 hours? Now it's really difficult. And we'll always wonder, right? What will happen after 2.5 hours? We don't know, right? Essentially, things remains the same. If in case we talk about our laptop or our desktops or our single workstations, but if in case we talk about actual business, actual enterprise, where there are hundreds, thousands of nodes and huge amount of clusters and probably lakhs of applications which are executing, thousands and lakhs of applications which are getting executed there, lot many things, the dynamics are quite high, and a lot many things may change after 2 hours, 2.5 hours, or 3 hours. So based on the future forecasting, based on foreseeing the future, right? How well basically things are going to be there, are they going to degrade or basically they're going to work northbound? Based on that, basically we can say, and using machine learning, we can say that yes, if in case you execute something probably 2.5 hours after, probably that is going to help you, right? You will get a faster execution. So these are probably the resource or time related challenges what we are dealing, and some of the difficult questions which we as a person can't answer, but it's only machine learning and artificial intelligence which can help us. Next are the root cause determinations, probably something right which are difficult, so as to identify the root cause, something which has something which occurred, ensure that right whatever the problem which has occurred last time doesn't occur in the future, right? So some breakdown which has happened in the last basically should not happen in the future. Now this is also again a machine learning problem, right, which can be solved. Alert me if in case something is unusual is happening, right? So unusual identification is also difficult, and we know, right, there are class of applications which talks about anomaly detections, change point detections, which helps us to not only detect the unusual, pinpoint the deviations from the regular activities, but also help you to reduce the noise and alert you for those occurrences. And last but not least, one more example is about the capacity planning. So whatever the cluster size, whatever the workloads which are executing, that as of now probably today are fine, but what if in case is this going to suffice probably 6 months down the line or 1 year down the line, or basically I will be requiring some less uh, resources or less applications or more applications or more resources. So that basically falls into an area of a spectrum of the capacity planning, and how much capacity will I require for after 6 months or 1 year or after 2 years basically is really very difficult to accurately predict, right? We can always do a hit and trial, we can always do a calculations mathematical, but essentially the accuracy of those machine learning algorithms, the outcomes from the machine learning and AI algorithms, and the accuracy from those calculations have been very different, and AI and ML are again winning the stack here from the manual calculations what we do. So what are the solutions, right? Let's get benefited from the artificial intelligence. So what we are presenting here, Jamboon is a part of an offering what we have created. And this is a solution which works in utilizing all artificial intelligence and machine learning capabilities for all the challenges, for all the questions what we discussed so far in these slides. And we believe that this is going to really help the customers, the end users, the data engineering teams, the IT teams, the data scientists, so as to better utilize the capacities, the technological stacks, and the capabilities. Because we are employing artificial intelligence and machine learning algorithms and models, we are also collecting the data, and we are coming up with the accurate results which are very magical in nature. So the kind of things basically what we are offering are like probably the predictive analytics, which helps us to predict the performance predictions, that how when this application is going to finish. Even without executing something, we can get to know when this is going to get finished. These are the employment, or this is how we are employing artificial intelligence and machine learning into a product. We can also proactively tell you that your SLA for an application is going to fail. We can also forecast the amount of resources basically which can be used. On capacity planning, we are forecasting the amount of resources basically which are there, the load and the workload, or the number of applications which are going to run probably 7 days after, or probably tomorrow, or 4 hours after, right now this time. Another important aspect is the event correlation. And event correlation basically instantaneously or continuously group all the activities, all the events, and correlate them, right? Correlate the occurrence of one event with the other and with the third one. And there are class of machine learning algorithms basically which helps us for the event correlation. What we do is basically we early detect the correlation of the points, and the points correlations which finally turns up into a breakdown of something, right? Probably an application or a cluster basically. What we do is like early breakdown detections and correlation of them, and alerting the user that this is the occurrence of the things, and probably this can help, this can again occur, and probably which can lead it to the breakdown, right? So probably early breakdown detection is an important, very important outcome which is out there. Same are like the anomaly detections, discovering the opportunities, what are the best time slots when something can be scheduled or can be executed, even the recommendations and the cost-based optimizations are again basically class of artificial intelligence and machine learning things what we are doing. And these all things basically have been put into this product Jambule, so which is an artificial intelligence powered APM. Uh, what we are doing is AI powered causations in a week. What it means is probably as you employ the product, you are going to get the outcomes. And essentially, this is just a turnkey solution. So as you employ the product, all the outcomes are going to come up. But yes, there are some data collections, there are some training which are going to happen there. So all those trainings and everything basically will get complete, and the all functionalities, so full featured functionalities. So a lot many functionalities of artificial intelligence and machine learning will start coming up probably in a few minutes or probably a few seconds or even in an hour kind of that. But entire spectrum of the artificial intelligence and machine learning things which we just talked about will come up, and all will come up as an outcome from this product in a week, right? So within 7 days, each and every algorithm, each and every training basically will happen, and you will get the accurate results from this product. So what this product is doing in artificial, big data and cloud territory. So if in case you are aware of probably the big data technologies, and I'm sure, right, lot many of you must have either heard or would have worked on these technologies. But when we talk about Spark, probably Databricks, Hadoop, and Hadoop flavors also, like Cloudera, Hortonworks, or cloud flavors of the Hadoop distributions like EMR, HD Insights, and Dataproc. Or on the right side, if in case we talk right in memory analytics, or SQL engines like Prestos, Impalas, or even data warehouses like Redshift, probably all these technologies are being supported, right? So we require a solution basically which is a single class of APM, which works across all these technologies and collect the data points, collect the occurrences, collect the workload, executions, and whatnot, and then come up with the artificial intelligence outcomes. Artificial intelligence outcomes we have already talked about, but just wanted to again refer them, right? So kind of an optimizations, predictions, efficiency detections, anomaly detections, recommendations, performance efficiencies, all these things basically are the outcomes which comes up from this product. So essentially data collection, employment of artificial intelligence and machine learning algorithms, and outcomes, presenting those outcomes to the users which are actually causables and which can actually help you to solve all the challenges what we talked about. So this is how we are a solution which is being offered here, and this solution basically employs and helps you to detect, push the APM into the big data and cloud territory. So in a nutshell, if in case we talk, this product can be leveraged on data lakes where we require data performance needs, or where we require to reduce the downtimes, or probably we require to reduce the cost. In premise and cloud, if in case we require a migration assistance from in premise to cloud, cost controls, or chargebacking of the internal utilizations. And last but not least, it's like business and IT teams, probably where we require to predict the runtimes in future, detect the root causes, or probably do the SWOT analysis. SWOT analysis is strength, weakness, opportunities, and threats of all the workloads, queries, and whatnot, and compare them, right? Using the historical workloads with the recent workloads, compare them as we compare the various offerings onto the e-commerce websites. See, these are the capabilities. So at whenever we require these things, probably we can leverage this product. These are the salient features. There are salient features in the artificial intelligence. There are categorized into the APM categories also, and all these things basically work proactive. So before they occur, we tell you, this product tell you. So before run assist, before failure, we help you to detect something. So all things basically doesn't happen right once the after the occurrence of the event. All these things basically are before run scenarios, and artificial intelligence and machine learning and proactiveness is helping us to do that. Thank you for looking at this presentation. I will quickly go to the product and will show you the quick demo of the product. So you can reach out to us, right? We are there at the Twitter, @Jambune is our Twitter handle. So you can feel free to follow us. You can also contact us, send across your enquiries, or if in case any questions or any suggestions or your willingness to work with us, probably you can contact at jambune.com, and you can also you can always visit the website, which is there at http:/jambune.com. Also, we are offering, as part of this special event, which is Pathmakers event, right? We are offering a free trial version, right, for an entire month, 30 days. And what we are doing is, like, full featured product is being offered. So you can always send across your enquiries at contact@jambune.com. You can just send across your nominations. We'll just qualify them, and we'll send across a free copy of this entire software suite to you. Full featured, free, no obligations for 30 days. Right. So just note down this number, and you can always mention the path makers in your mail to us, and we will be happy to assist you from there. Sure. Thank you. We'll just quickly go and present you the product also quickly. Okay. I hope my screen is visible. Now, what we are seeing here is probably the inefficiency detection, and lot many things basically are getting powered from artificial intelligence. So what we are detecting here is the utilizations which are happening, the long running applications which are getting executed, probably the applications which are going to miss the SLA in future, right? So something basically SLAs which we have thought of, and something which is going to miss, and how long basically they are going to get executed, right? So this is also something which is empowered by machine learning. As we get into the product, probably these are like whole class of, right, the solutions or offerings, but basically what we are giving on the detection side, there are anomaly points detections, change point detections, how we can see the congestion. Probably on the optimization side, the strike rates and the queue utilizations. On the forecasting of the clusters, probably we already talked about the capacity planning, forecasting, the failure events detections, and chargebacking. Especially for your big data workload services, what we have is, like, performance predictions of applications, running applications, the cost-based recommendations, cost-based optimization recommendations, time slot recommendations, anomaly detections, and host of the things on the detection side. On optimizations, we have got workload optimizations for each and every individual workload, whether they are Spark, SparkQL, Hive, MapReduce, these, and machine learning programs or workloads which are written in Spark. And then on forecasting on the cluster side, we have got SLA overshoots, we have got performance predictions. So even something which has not executed, we can predict the performance and can also give you the forecast. And we got host of services basically for workloads, for data, for cloud, for containers, for stores, for streams, and SQL engines, what we talked about. So I probably will show one or two things to you as part of this demonstration, and we can always talk separately, as I'm slightly over the time and would like to quickly finish it off. So I can go into the optimization probably, and what we are seeing here is, like, the scoring of the underlying queues, which are the fast queues where you should submit something, and which are the average queues where you should not submit something, right? Probably that's, like, probably one thing which will be really helpful if in case we talk about the detection. So this is also getting powered by the artificial intelligence. So something which has occurred in the underlying cluster, and probably which I can use, probably how efficiently those things are coming up. So all these powered by the artificial intelligence, either the forecast of something queue, which is like for the future, the available time slots. So when the future time slots are going to come up, and when can I execute something, how long are those time slots, or probably the anomaly detections or change point detections which have occurred, right? So probably I can see that also, and whenever the anomalies or something change points occurred, probably I can also detect them and can also get into that what is the root cause for these things. One more interesting magical thing probably is something on the workload, and what we can see here is the prediction. So if in case I go on to the prediction, what I'm seeing here is an applications which are executing, and you can see this is powered by artificial intelligence, where I am also predicting that when in the future this is going to get completed. So as of now, these applications are running, as we can see from this state, and the amount of time basically this is going to take in future to get finished off, probably precise time and with a very high accuracy what we can get. So these are about the running applications. What we can also do is anything basically which is not executing or not running. We can also tell you when it is going to get finished or how much time basically is going to take whenever you are going to get executed. So if in case you execute something right now, it's going to take probably 5 minutes. And if in case you execute something in future, probably it's going to take X, Y minutes or 4 minutes or 6 minutes, depending on the underlying state of the dynamics of the various workloads or the clusters and whatnot. So this is a quick glimpse of the product. Just wanted to show you, and you can always reach out, right, to us as being showed by me in the presentation. So I will quickly go and we'll just show you the presentation. I hope basically that should be visible. Okay, so just coming back to the last slide. Yeah, so thank you. This is just if in case you are not noted down, right? Probably Twitter handle, the website, and the way basically how you can contact us for availing the offer for this Pathmakers event. What we are offering, a full featured product for 30 days with full assistance and no obligations. Thank you so much. I will let Survi to say if in case she has some questions for me.
Yes, Mayank, we have received a couple of questions, but since we have overshot the time, I would just be taking one question, which you can take it up quickly. Rest, I would just want to keep the attendees informed that for the unanswered questions, we would be getting back to you personally on your email ID. We'll answer your questions. So
Sure.
it would be taken up, but it would be done separately. Okay, so the question says, what are the prerequisites to be master on before learning cloud technology?
Um, yeah, that's a very interesting question. And essentially, the prerequisites are probably the mathematical understanding, the ability to understand the mathematical calculations which are happening behind the scene. Also, one more important aspect is ability to sense the data, right? Because everything basically which is machine learning and all these things basically are going to work on the data, right? So data sensibility, data sensing is a very important aspect. So we require to understand the dynamics of the data, what is this data and what about that data. And probably based on these two things, we can always devise the algorithms and we can always crunch the data to the perfection, which can help us to deduce the most accurate results. But if in case we employ the tools like these, probably we can hotwire each and everything. So we don't require to experiment with the data. We don't require to experiment with the models and machine learning and AI algorithms. We can directly apply this product and can get the outcomes. I hope this answered the question.
Yes,
Okay.
thank you, Mayank. Thank you.
And yes, again, right, unanswered questions, basically we'll reach out to you and we'll send across over the email. Thank you so much.
Definitely. Thank you for the session and the insightful
Appreciate your time.
details.
Thank you.
Thank you. Thank you.